Yeah, it's live, right?
Just a second, I'm checking.
I got a notification that it's live from my LinkedIn.
Yeah, we're live.
So I'll start now.
Right.
Hi everyone, good evening. Welcome all for joining us today for this webinar. First and foremost, I would like to thank everyone who have taken time from their weekend to come here for a session of great learning, right, on React 18. And thank you, Kirti, for joining us also today, spending time with us like today. Before we start off with the webinar, like I would like to introduce myself. Hi, I'm Candida. I'm from the Recro team and I'm from the community team as well of Rebase. So I hopefully who all is here are part of Rebase, but those who have not heard about Rebase or is coming across Rebase for the first time, I would like to give a small context about Rebase. We are a developers community who is active on Discord. We are having around 225,000, plus developers who is learning and growing every day. So, being a part of our developer community means certain perks are there, as in like we keep exclusive mentor hours just for our members on interview prep, DSA session, career guidance, right, from mentors from like really prestigious companies such as Microsoft, Google, etc., like that. So this provides an opportunity for our members to learn and grow. Apart from this, we also have like exclusive mentor meetup. I mean, members meetup where we provide a platform for our members to come and meet each other in the city itself. As I'm speaking right now, we actually have a member meetup in Bangalore, right? So this is about Rebase. If you are coming across Rebase for the first time, do check it out. Like, do hop into our Discord server, explore, connect, and you can build connections there. So before we kickstart like that, I would like to introduce Kirti, who is our speaker. And today is like a very special day for us because it's the first time someone from Recro has joined and is a speaker like that. We usually have speakers from different companies like that, but it's the first time we're having someone from Recro like that. So we are very excited to have finally someone from our team itself come as a speaker, and she'll be given her expertise on React Agent, concurrent rendering like that. A small introduction about Kriti. She has like around 5+ year experience in as a software developer, and she loves to design and build digital experience. And she believes like keeping things simple is the best user experience, which I think is something like everyone should have. Like it is the best way to go about with things to give their customer best user experience. So we are very thrilled to have you here, Kriti, with us. Yeah, you can just give a small introduction about yourself.
Thank you so much, Candida. I think you covered pretty much what I had to say. All I would say is that I started as a cybersecurity consultant and then moved to software development. So, been majorly working as a front-end engineer and some experience with backend. Experimenting a lot, learning a lot from the community, and I think Rebase, thank you so much for giving me this opportunity.
Yeah. So before we start with this webinar like that, I would just like to point out few things for who all have joined. As I mentioned before about Rebase, this webinar is powered by Rebase. So who all have not been part of Rebase yet, I'll be providing our Discord link in the comment section like that. You guys can hop in and join our server, and just can explore and build connections like that. Uh, Second thing is like we want to keep this webinar really interactive and live. So please do put on your curiosity cap, like ask as much as questions you guys want. Kriti will be sharing the questions with Kriti, and she'll be happy to take the questions with us like that. So yeah, so let's kick start with the webinar. Yeah, Kriti, you can over to you.
Yeah, so share my screen. Let me know once you are able to. I think my screen share is disabled. Candida, can you please enable it?
Canada, you can click on screen share and you will get an option to enable it for speaker and the host. You're on mute.
Yeah, can you share now?
Yep. Mhm. Okay. So guys, Concurrent React is a foundational update to React's core rendering mechanism. It's a new behind the scenes, mechanism that enables React to prepare multiple versions of the UI at the same time. So you can think of concurrency as an implementation detail. It's valuable for the feature that it unlocks. The reason like we are talking about this today is I feel like React 18 has brought along a lot of features, but if we do not know the basics of how React works, under the hood, or what is the purpose of React, or how a state update happens, it's difficult to wrap your head around, or not difficult, but might take some time to wrap your head around the concurrent changes that React 18 introduces. So today we will be covering, how React manages updates and rendering efficiently. We will explore the inner workings of React by diving into the fiber reconciler and scheduler, learn more about the asynchronous rendering nature of React, and also examine how scheduling and deferring of updates occurred using priority queues and render lanes. So the goal is, to help you build a solid foundation in understanding the mechanisms that drive React performance and how intelligently it prioritizes and processes updates. So before we start with, all the features or understanding everything, but it's important to understand why we need concurrent rendering. So with React or any front-end framework, the goal is always making your web applications more performant. But we know that JavaScript is synchronous and single-threaded. So by default, the browser uses a single thread to run all the JavaScript code on your web page, as well as it handles user events, performs renders, paints, layout changes, and reflows, and also garbage collection on the same main thread of execution. So this means that, long-running JavaScript functions can block the main thread, so leading to an unresponsive page or a bad user experience. Just a second. Is this Zoom participation banner visible to you guys over the slideshow?
Which banner, Kriti?
So are you guys seeing just the slideshow with my slides, or are you also seeing the, my talking face of
Yeah,
the...
we can see the slide as well and you as well.
No, I mean to say over the slide, for me, it is like the Zoom banner is visible. I think it is not visible for you, right?
No, it is not
Okay.
visible for me. We can see
Okay.
the screen share also and you as well.
Okay, cool. So it was just checking that. So, so it's what I was saying is with the long-running JavaScript function, it is easy to block the main thread, leading to an unresponsive page and a bad user experience. So unless we are intentionally using a web worker, JavaScript runs everything, all of this on the main thread, and it can, like, delays in event processing or painting can lead to a frustrating user experience. So that's why there is something like rage clicking that happens, which I'll show you in a while. So the less the work is required on the main thread, the more the thread can, respond to user events, pains, and generally be more responsive to capture user interactions. So let's understand what we mean by long tasks. So in concept of the browser, a long task is any task that takes more than 50 milliseconds to complete. It is an uninterrupted period wherein the main UI thread is busy for like 50 milliseconds or longer. Common examples of why this happens is running event handlers that are, really long, involve expensive reflows and other re-renders, or the different work browser does between, turns of your event loop. That also sometimes can exceed 50 milliseconds. So these tasks are actually visible on your performance tab. So if you capture the performance, of your web page and see it in the main thread section, these tasks will be visible with a red tag on the top left corner. Like in this page, if you can see the yellow tasks with a red tag at the top right corner, these are usually how long tasks are represented in the performance tab of your dev tools. So now, so this can lead to frustrating user experience. For example, in this case, I think the GIF is not visible here. So I'll shift to showing it to you guys on my browser. So this is where actually the user is trying to click the different options available, but the user is not actually getting a visual feedback for the click. Maybe the click is getting registered, but because the user is not getting any feedback, this rage clicking occurs, which again is a bad user experience. So apps these days, handle a lot of complex data, and, it's easy to have long tasks which block the main thread and restricting user interactions. So, and it is also a known fact that mobile devices are generally slower than desktops and laptops, and this effect can be amplified in your mobile devices. The metrics that is used to evaluate such kind of responsiveness is called first input delay and interaction to next paint. So every year, I think there's a site called HTTP Archive, which releases reports on performance of websites in the Chrome UX reports on web and mobile devices. So they actually put out a survey every year on the performance of different websites on different devices and how it has improved over time. So in case if you would like to know and research more on it, you can go and check for the HTTP Archive reports. So that's why, that is the reason why actually concurrency is important, because it's important that certain tasks we handle asynchronously and we can manage and schedule them better so that the main thread is not blocked and it is more responsive to user interactions. And if we do not do it, it can actually impact your business metrics, that is the conversion rates might drop because users experience that your app is slow to respond. So now that we know why concurrency is important, let's also first look into how rendering works under the hood in React. So React's virtual DOM is we know that React has a concept of virtual DOM, which is nothing but a blueprint of the desired UI state. So React takes this blueprint and through a process called reconciliation makes it a reality for a given host, like a web browser. So any visual update in React actually takes place in two phases. That is the render phase and your commit phase. The render phase in React is a pure computational phase where React elements are, compared to the existing DOM. This phase involves creating a new tree of React elements, also known as the virtual DOM that we just discussed, which is essentially a lightweight in-memory representation of the actual DOM. So during the render phase, React actually calculates the differences between the React current DOM and, or you can say, we also know that React does this using the fiber reconciler. So you can consider this as a current fiber tree and a work in progress fiber tree, which we'll discuss in some time. So it basically calculates differences between the current DOM and the new React component tree, and it prepares for the necessary updates. And following this phase is actually the commit phase, wherein React applies whatever updates were calculated during the render phase to the actual DOM. So the commit phase is actually what involves creating, updating, and deleting the DOM nodes to mirror the new virtual DOM. So in a typical render, or whatever we know of React up until React 18, these both phases would happen in one synchronous sequence. So first the commit phase and first the render phase and then the commit phase for every component or every update, we can say. Next, we'll move on to understanding something what is called the fiber reconciler. So fiber reconciler was introduced in React, I think React 16. Before that, there was, I think, the stack reconciler that React used to manage the updates and the diff changes in your virtual DOM. So when React actually introduced a fiber reconciler, it was a significant architectural shift from the previous stack reconciler. And the primary goal of the fiber reconciler was to improve the responsiveness and performance of React applications, particularly for large components and large and complex components and user interfaces. So the fiber reconciler achieves this by breaking the work of updating the virtual DOM into smaller and more manageable chunks, which is called units of work. So any unit of work in React language is considered as a fiber. So, and this can be executed asynchronously on the main thread. So at its core, a fiber data structure is a lightweight representation of a component and its state in a React application. So the fiber data structure actually is mutable and can be updated and rearranged as needed during the reconciliation process. So if I have to show you. So we can consider a fiber is actually nothing but represented as an object in the memory. It contains information about, the component it represents, including its props, state, and child components. The fiber node also contains information about the position of the component in the tree, as well as metadata that might be required for fiber reconciler to prioritize and execute updates. So if we see that we have something called element type in a fiber data object that is represents what is the HTML element type. We have the state nodes, which will carry all your state data. And there's a return, which is nothing but another fiber node, which represents the parent of a particular fiber node. Then the child fiber nodes, sibling fiber nodes, some, props and everything. So all in all, and also the effects that have to be executed side effects, which we, define using the use effect hook. If you guys are using, you probably should know. And also something called lanes. So this lanes is a concept that is very important when it comes to concurrent rendering in React, and we'll revisit this later. But as of now, this is like the basic structure of your fiber node in React. So next, so your fiber reconciler actually uses a work loop to process the updates, and each iteration of this work loop updates a small portion of your virtual DOM. So one by one, it traces and creates your fiber nodes for the component and the updates on the component. So it updates the virtual node by creating a new fiber node for each component and updating the relevant content for that particular fiber node whenever a state change occurs. So, but what happens is these changes might not be immediately applied to the DOM because, instead it is stored in the work in progress tree or the updated virtual DOM that we were checking here. So there is, for the fiber reconciler, actually uses something called a process of double buffering, wherein it has the current tree which exactly matches your current DOM, and then it has a work in progress tree or your updated virtual DOM, you can say, which will store all the updates that have to be pushed to your DOM after when it is processing a state change. So it's a work in progress tree is nothing but a copy of your DOM that is used to render the updated content. By using this, a fiber reconciler can avoid making unnecessary updates to the real DOM, which can, improve performance and reduce flicker. So once the update is complete, then the fiber reconciler actually switches your real DOM with the work in progress tree. So this is like, you have a work loop, which calls again your begin work and complete work and commit root. So if I have to summarize this a little bit, I would say that your fiber reconciliation involves comparing the previous virtual DOM to your, or you can say the current tree to your virtual DOM, whether it is updated virtual DOM or the work in progress tree, and figuring out which nodes need to be updated, added, or removed. Then during the reconciliation process, it creates a fiber node for each element in the virtual DOM. Once the fiber nodes have been created, it uses a work loop to update the virtual DOM. And then the work loop starts at the fiber node, which is usually your root wherein the change has to happen, and works its way down the component tree. So, and then making each fiber node as dirty. So this is what your begin work function actually does. We'll see that in a while. And if it needs to be updated, it will mark the component as a, with a dirty flag. And eventually, your complete work will commit all your changes. So whatever your changes have been calculated, that will be pushed to your DOM. And this is what the commit phase does. So if we see the fiber structure, can be something like each fiber node has, a child, sibling, and return. Return is nothing but the parent fiber node. So fiber tree travels, this is a rough structure. Consider what we just visited, the fiber data structure some time back. Based on that, we can just at a high level think of a fiber tree as this sort of a structure wherein you have a root, parent, and then child. Each component will have a child and may or may not have a child, may or may not have a sibling. And then so your fiber tree traversals is kind of a depth first search, wherein you go from your parent to child to sibling, if there is any. and then back to parent. And every node is actually visited twice. We go from top to bottom in begin work. That is, we go marking if any component needs to be updated, and we go from bottom to top in the complete work function. So you see that in this work loop, every fiber node is actually visited twice with begin work and complete work. And you can actually think of it as if you all are complete beginners, you may not know, but if you do have worked with the DOM manipulation and events in your browser, you must know that there is something called DOM event capture and bubbling phases. So we can think of the begin work as the capture phase and complete work as your bubble phase of event updating, your DOM manipulation. So your parent node will always begin update first, and then it will complete after all its children have completed working. So once your work loop is completed, the fiber reconciler switches the real DOM with the updated virtual DOM or your work in progress tree, and ensures that the UI is smooth and user gets a really good update experience. So for before we move on to the next session, I have a short demo to show you guys. So let's begin with that. So we'll see actually how actually first render of React takes place. Okay. So I have this basic app. I have created it using CRA, and it does nothing. It has the app logo of the basic CRA and just a count, just one state. It's not even clickable. Just we have set a count state object with use effect, and we are displaying it. That's it. And we'll place a debugger, one outside of the use effect that is inside the component, and one inside the use effect, and see like actually what happens. So whatever functions that I've been talking about, how it is actually run. Yeah. So I think one of you is typing. If you could mute, please.
Yeah, done.
Thank you. So we've started running our app, and we see that we have hit our debugger that is actually run first. So what we are trying to do here is just understand how and when the DOM is actually getting manipulated. So your first debugger actually is run or hit when the component is run. So if you can see the call stack here, it actually begins with your React DOM root render function. And then you have the update function being called, update schedule on fiber, ensure. We will see all these functions in a while. And the work loop that I was talking about. So the work loop is actually where your fiber tree is working on your updates. And then we have begin work. So we have just started beginning the work. Nothing is done yet. Now let's play this and see what happens. So now this debugger is inside use effect. And if you see in the call stack, the commits are done. If you see, commit passive mounts, commit hook effect list mount. This is all actually done. So, and we can see actually that your component is mounted. So the initial state of this application is actually mounted on your UI and we are able to see it. But still the use effect, whatever logic we have applied inside use effect, that is not get applied still. So once we run this use effect, now it has gotten applied. There's also one way to check when your DOM being manipulated, or there's one way to add a breakpoint. That is, if we have to run this again, and let's do one thing. So to understand when actually the DOM is manipulated, we'll click on the div of the root with ID root and go to break on and click on subtree modifications. So what this actually does is it adds a breakpoint for your DOM manipulations, and will then actually try to run it again. So again, we have revisited all those functions that we discussed, and we have hit the debugger. I'll play it, and you see that here we have hit the debugger or the breakpoint again when your DOM is actually getting mutated, or your changes are applied. So if you see this here, earlier we had not seen the commit root in the call stack, but now we're able to see, because here is actually where the DOM manipulation is happening. And since we have hit the breakpoint, we see all these, the commit root again in the call stack. Again, I'll make a play, then we'll go to the use effect. And again play, and we have the changes here. So this because now we have hit the breakpoint, or we have set the breakpoint for every DOM manipulation. If I play, first the debugger was being breakpoint was occurring only as at the two code places that we have the debugger we have added inside the code at two places. But now every time, every place your DOM is getting manipulated, the debugger is playing. Okay, cool. So if you go to C, just a second. This one. Yeah. So this is your entry function, which is like, the user, whatever code you have written user side, that will be added or run from this point. And then there is schedule update on Fiber, which is actually tells React where to render for the initial mount. There's actually no previous version, so it is called on root only. And then you have the ensure root is scheduled. So this function is important to call the perform concurrent work on root. Again, this function that we have here. And we'll see all of this in a while. This is actually the part of the scheduler. Then you have the schedule callback, which actually, which is actually where the React scheduler comes into picture. And your work loop, begin work, and your commit, complete work, commit root, all of this. So if I have to give you an overview, here's my Excel draw. How do I hide this thing?
Kriti, need some help?
Yeah, so how do I hide this banner for
Which banner?
Okay, so on your Zoom, when you're sharing your screen, you have this banner, mute, stop video, participant and all, right?
Oh, you okay. I think there would be a small arrow on the top of it. If you right click on that, I think you will be able to do it. Can you try? Because as of now, I can't see it. So
I mean, it's just appearing to me. Those are
yeah,
Zoom.
Those are, I think, navigation
Yeah.
bars, right? Yeah.
I moved it down, so it should not
Got it.
be. So, all in all, if I have to put in, a sort of diagram of how actually the first render happens, so it's actually this. So your render function of React DOM or your set state will trigger the update or trigger the render for your application. And then since all the work is kicked off here, I have just called it like, trigger sort of. So then we can think of this phase as what you call create a task, or, begin working or begin your fiber root changes, all of that. And here, so once your set state or render is called, there's an update on the fiber tree that is scheduled, and you call the ensure root is scheduled function, which again calls your scheduled callback. So you might not understand this exactly, but just know that there's a trigger. There's something that is causing your state to trigger, and then based on what the state update has triggered, your scheduler takes care of creating different tasks and updates and scheduling it. And then there is a render phase wherein all your changes for the computations or for all the computation is happening to actually understand and record the changes that will have to be applied to the DOM. And then your commit phase wherein actually those changes are, actually are getting applied to your DOM. Hope everyone has gotten at least this overall idea. The functions may not, you may not understand it right away, but at least if you understand or take away some of these function names, and if your curiosity peaks, you can go to the React package and actually explore the inner workings of React. So, moving on to next, understanding what is actually a concurrent render and a blocking render. So before we actually, I'm just taking a basic example of this product page on an e-commerce site, which has, the basic layout component, search section, sidebar, product section with the image carousel details and your reviews, and the add to cart option. This is just a example that I'll be considering to demonstrate something ahead. So before React 18, React could only handle one task at a time, and a task could not be interrupted once it has, started. That is, if there is an update, React will process it synchronously in one single uninterrupted block. And the problem is that if user events also fire in the main thread, so if the rendering process is going on and user clicks onto something or user starts typing something, then it would not register it. So it cannot be processed until the current rendering process is completed. So this is actually what refers to blocking render. And before React 18, all the versions before React 18, all of the renders that happen are actually blocking renders only. Everything is rendered synchronously once, of course, a state update starts. So what this means is that if users have to wait until the render was completed before any new change could be seen, and React would give the same priority to all elements within the component tree. So when a component tree is rendered, it will actually either on the initial render or on the state update, React would go ahead and render the tree in a single uninterruptible task. And after it gets committed to the DOM, the visual updates will be visible. And it's guaranteed that, so in this sort of approach, it's guaranteed that if a component starts rendering, it will finish. Nothing can interrupt it. So if you just think in this way that when your component was rendering and when the image carousel was still rendering, user just clicked on it. You just clicked on it and nothing happened, because the user input will be only handled once all your components have been rendered. So there's actually a delay. So between the user actually clicking on something or interacting with your app and the user actually getting a feedback. So if that delay is like your entire rendering of this product page takes 2 seconds, and user has to wait for the entire 2 seconds to be complete to interact with your app. And that is fine maybe, but if we are on a slow device or on a slow network, this can actually be kind of frustrating, or not frustrating, maybe also frustrating, and a bad user experience in general, because your first input delays will be higher, interaction to next pane that we had discussed earlier will be higher. So for this actually comes into picture again in server-side renderings also, wherein all of your hydration occurs in case of server-side rendering, and your user is able to actually see the content, but until the browser actually downloads all of your code, React and JavaScript code, and hydrates the application, the user cannot actually interact with it. So again, this all is a cause of blocking rendering, because that is how React has been rendering, up until now. So again, demo time. So I have a app which is actually artificially made to run slowly. So what this app has is it has an input field, and which is nothing but basically a search filter. And based on whatever query you're searching for, the list will be rendered. And the list is also not, we are not making any API calls. I have just added some JSON here, and it's just an array of objects. And this is the app, basic app. The way I'm slowing it down is using a sleep function. That is it. That's it. There's no more great things happening here. It's just slowed down artificially in case using a sleep function. But this is just to demo you guys. If we are actually on a slow device and on a slow network, and if the user tries to type into the text field, which in turn leads to changing a bunch of components, maybe the list or something else, that can trigger React to render all the components. And because in a blocking render, React gives the same priority to all, think about this. You have to also update your input field with the query that the user has, is typing. And also, based on that filter search query, you have to also update your list. So all of this is actually given the same priority. Now I know you guys are smart and there are optimizations to avoid this to happen. But let's just think the basic React app, no optimization on top of this, just this. So in blocking render, nothing can happen until React is done rendering everything. So let's see what actually the problem occurs. Did I change it? Okay, I did not change it. in the index page. Let me just change your app rendered to your demo app, which shows the document. So this is your basic app, and one input box and whatever object list object we have put there. Now see this, okay? I'm trying to type something called. So I clicked backspace. It should have been released, but it's taking time. Where is it? Just a second. Give me a second. Okay, again, let me just type LUX. I typed it, but it did not immediately show. And when it showed along with the filter. So ideally, LUX in the input field should have been shown immediately. And okay, it's okay if your filter takes some time, you can add some loader there. But both of the changes appeared on the screen at the same time. Again, I removed X and U, still taking time. So is there a breakpoint going? Oh, this is why. Let me remove this. Okay, now again, and I'm removing it, and it's taking time. The changes are appearing at once. I know people will use debounce and throttle and everything for it, but if you're not using it, this is how it happens in a blocking render in React. If I try to type something else, again, I typed GRAN and both changes appeared at the same time. And the input was not real time. So the input change, which actually has to be high priority, because to imitate real world scenarios, all your key presses, the user actually has to see it, immediately. Only then it feels like a real time experience. But here, when I type it, it's not showing up because the React is busy performing the render. Only after that is completed, I'm able to see this. So we understand now that, what is actually the problem with blocking render. Now, how to actually, so in React 17 or like in any versions before React 18, you would use React memo, maybe virtualize the list, use debounce and throttle, all of this. I'm pretty sure you know these concepts. But if it is not the case, this is the basic nature of React, and how do we solve for it? Okay, so now you may ask a question that if, locking the main thread is the problem, can't we do all of the work, inside a web worker? And, just offloading all your reconciliation and VDOM to a web worker. And like that is a general query, which obviously the React team also might have thought upon. But what they came up with is that web workers are sort of limited, and they bring along with web workers, you have overhead of initialization, memory initialization, and serialization. So, and it doesn't really was helping this case because the use cases were limited. So what the React team points out is that, this is not actually a performance problem, but rather a scheduling problem. So React team figured out if they could somehow enhance React to be able to differentiate between low priority work, like rendering a list, or, it's already full. Okay. I think the session will go beyond 1 hour, maybe a little bit. I hope that's okay for you guys. But Yeah, I just saw the time and I was like, it's already about to reach 4. So React team actually was, tinkering around this thing, and they wanted to render, differentiate low priority and high priority updates. So they implemented this scheduling thing, which and called it Fiber, a completely new name, and like to change to their core reconciliation algorithm. And it was released in 16 only, React 16 only it was released. So the ability to opt into async rendering was actually there when this React Fiber and scheduler was built, and it was released in React 16. But what was a more challenging part was that the API to expose to what API to expose to React developers to take benefits of this concurrent rendering. That was a more important discussion actually. So I think in 2018, Dan Abrahamov from the React team actually gave a talk on time slicing, and over the years actually it went through so many changes. So they kind of thought of calling it async rendering, concurrent mode, concurrent rendering. So finally, after so many years, they could figure out ways of exposing the concurrent features to developers. And if you see, it's been like what, 5 years or so up until the usable version of concurrent features was released and people could use it. So if you see, a lot of work had to be done in the background. That is the fiber rewrite, error boundaries, change, context. Hooks also was in a way introduced to, support concurrent rendering, and the dev tools rewrite plus profiler, your scheduler changes, a lot of changes in suspense also to support all of this. So after all of this is in React 18, we could actually get concurrency. So now let's see what is actually concurrency. So concurrent React is actually the main concept, or the main property of concurrent React is that rendering is interruptible. So when you first upgrade to React 18, and before using any of the concurrent features, the updates are rendered in the same way as it was in the previous versions of React. That is, a block. It is still a blocking render only. Once so, but sorry. So as the React team actually, introduced in their or spoke about in their React 18 release, if you're not using the concurrent features explicitly or using use transition or deferred value or suspense, whatever that is, your React 18 will also work as React 17 only. So concurrency or the concurrent features are actually opt-in React 18. So you can choose when you want to use them or when you do not want to use them. So we have seen this 2 phases of an update earlier, that is the rendering phase and commit phase. So what we say when we concurrent rendering is that React has the ability to pause the work in the rendering phase to allow the browser to process events. React can either resume, throw away, or recalculate the work later as appropriate. But once the render pass has been completed, React will still run the commit phase synchronously only, because the changes have to be applied to the DOM in one go. So when we say concurrent rendering, we're actually just talking about this rendering phase. And only this rendering phase is interruptible. Commits to the DOM have to actually happen in one go only, and they cannot be interrupted. But the rendering phase that we had discussed, that is actually interruptible when it comes to concurrent React. So before concurrent rendering, every task started and executed linearly, and the code, if the user even interacts with the code, they wouldn't get feedback immediately. So React, what it does is, now in React 18, it utilizes something called cooperative multitasking model. So there's still a single rendering thread, but it is interruptible. So the rendering can be interleaved with actually other main thread tasks like user input, network events, timers, animations, browser layouts, and paints, all of this. So because of this low priority update won't actually starve a high priority update. So what if we think about, user events, they have to be treated like highest priority. So, and the low priority, like we have seen in the demo, when I was typing something into the input field, it was also not appearing on the screen. So that actually has to be high priority update. The filtering of the list can be a low priority update. So this low priority update can actually happen in the background without actually blocking the user from, seeing the input that they are typing. So the concept that time slicing or your cooperative, modeling introduces is that if your device is fast enough, everything feels like, okay, it is synchronous only. But if your device is slow, at least your app still feels responsive. Okay. So if we think about how that occurs, is that your React uses kind of heuristics, which they call it, your rendering phase is executed in a batch of 5 milliseconds. So after every 5 milliseconds, React will actually give control back to your user, back to your browser, so that it can register user inputs. And this 5 milliseconds is actually not a magic number. It is smaller than a single frame on a 120 FPS device. So it won't block animations or anything. So that is actually what is the heuristic that React team is using. So if we think there is a task queue and a low priority task is going on, so React will actually render it, the whatever state change or component change has occurred, that has triggered a work or a DOM update, that the rendering for that will happen in batches of 5 milliseconds. So after 5 milliseconds, the control is given back to the user, and in case in between that a user input occurs, that can be actually handled immediately by the browser, and that will actually be considered as a high priority task and immediately synchronously rendered. So in our example, if it was concurrent rendering with React 18, we could immediately be able to see the input query that we have typed, and then slowly, once the high priority task is completed, React will go back to rendering your low priority task and finish it. So it's like, in the context of React, concurrency refers to having one or more tasks in progress at once. The concurrent tasks can overlap depending on which is more important. So it's 1 hour is over. I'm pretty sure that, you guys must are listening to this talk, but again, might be using your phones. So if the notifications pop on your mobile phone, that is more urgent to check. So you will pause listening to me or even skip it maybe, and then attend to your phone and come back and continue listening once your task on the phone is done. So, but meanwhile, I'm still continuing with my talk, right? So it's like at different points through the talk, your focus shifts from on what is more important. So concurrency is just like that. Of course, in this case, focus or like more important work is the notifications on your phone. But yeah, concurrency is pretty much like that only. So with our example that we had considered earlier, when it comes to the product page, now if while rendering the image carousel, there is a user input occurring, with concurrent rendering, it will be immediately handled, and then the other components will proceed to rendering. So let's understand how does your browser keep the React keeps the browser interactive. So we know that rendering React concurrent rendering with concurrent rendering, React now prioritizes high priority tasks, and low priority tasks can be interrupted with high priority tasks. So we need some logic to pause these tasks and resume, and that is where we have the scheduler package. So what the main function of or primary responsibility of your scheduler package is to manage the processing of renders or updates based on their priority. So to effectively manage scheduling of updates, React assigns priority levels to each task. So these priority levels help the scheduler determine the order in which the tasks or updates should be executed. High priority tasks are prioritized and processed immediately, while low priority tasks can be deferred or interrupted as needed. So once the high priority tasks are completed, low priority tasks can start or resume where they left off. So now there are, to understand what for this priority, there in React, there's actually 3 levels of priority. This might get a little confusing, but let's try to understand this one by one. So you know that React has something called a scheduler. Events are nothing but the user events, and lanes. We'll look at lanes also in some time. So the different you have something called scheduler priority, which prioritize your task in your scheduler. You have event priority. So based on what the user event is, there can be clicks, key presses, which are higher priority. Mouse overs or hovers can be, medium priority. So that also, events also carry certain priority. And there is lanes, which, so your fiber tree actually has tasks and works to do, right? So it marks the priority of that fiber node update. So lane is, we'll look into it in some time actually. And if you see, it's interesting. So this function ensure route is scheduled in your fiber loop work loop actually maps this. So what we can see from here is that your scheduler priority is derived from actually your lane priority, and then like your lanes are mapped to event priority, and then you get your scheduler priority. So it's like events, your immediate user blocking. So these are the different scheduler priorities that we have, and these are mapped to event priorities, and again your lane priority, which we'll see in some time. So scheduler events, priorities have some timeouts associated with them. So if it is immediate priority, for synchronous tasks, the React assigns immediate priority, that actually times out immediately. And user blocking priority has a timeout of 250 milliseconds. Normal priority has timeout of 5 seconds. Low priority has timeout of 10 seconds. So you know that React 18 actually has introduced use deferred value as a transition or a hook. So that you can use to actually defer updates. So they can be assigned your low priorities or to defer them a little. So what React does is it actually evaluates each task and assigns a priority level based on its nature and the current state of the application. The priority levels have like, different timeouts assigned to them that tell React that when to run what tasks. This actually enables React to execute, high priority tasks earlier. Next, moving on to render lanes. So we have spoken about priorities, but what is, actually the granularity or of this prioritization? So render lanes actually help us determine that, and it's nothing but a lightweight abstraction that around bit mask that React uses to prioritize your work or fiber node updates. So it is nothing but you have a 32 digit or like 32-bit mask, right? So if one bit in that 32-bit mask is set to 1, that will become one lane. So now if you can think, there are 31 times you can do that. So every bit, if you change to 111, that will form one lane. So lanes are nothing but they are just numbers, bit masks actually. But we assign some meaning to them, and that actually makes it helps us with prioritization. So there are actually 31 lanes because that's how many one digits you can fit in a 32-bit bit mask. And each lane actually corresponds to a specific priority level. We see that you'll see that in some time, but from this function, you can get a base idea that you have discrete event priority, which is like the clicks, and your key presses actually take the utmost priority. So they are assigned your immediate scheduler priority. Continuous event priority are again take user and user blocking scheduler priority. So these are different. So I'm not sure if you are able to view this clearly, but if you see here on the screen, there are 32-bit integers and just 111 bit is changed in each of them. And that actually forms your different lanes, and there are certain names given to it. So when we speak of use transitions, we can see that there are 16 transition lanes, and that is what when you use transition, your update will fall into this transition lane. And again, in your scheduler priorities .js file, you have your priorities assigned. So no priority is 0, immediate priority is 1, user blocking priority is 2, as like that. So again, back to render lanes. So every update in React is actually assigned exactly one lane. And if 2 updates are assigned the same lane, that means they will always render in the same batch. So render lanes also allow batching of updates. And that's why it is important. And why the concept of bit mask? In the sense, if you see, bit masks are nothing but numbers. So you can perform operations on them, and that actually, every component tree has like a bit mask field. And so lanes, it actually allows us to perform bitwise operations so that React can figure out if you need to merge lanes or intersect lanes or remove lanes to decide whether to discard an update or when to push for an update or when to, pause and abandon an update. These bitwise operations actually help in that. And that's why I think the React team chose to go ahead with the update render lanes concept. Now a little bit before we dive into the working of a scheduler, it's important that you understand that there are different queues that React uses. So one is your sync queue, then is your task queue, and your update queue. So update queue is nothing but your holds. It actually holds future updates. So every time a set state is triggered, the update value, your values or your any states are not updated right away because they may have different priorities, and you need a way to actually store what the update is, and then based on their priorities and their timeouts, the scheduler will actually schedule tasks for them. So the update queue will actually hold your different updates. And if you can see the structure of the update, it actually has a lane, a property in it, then action, eager state, next state, all of that. So every update will have a lane that holds a priority for that update. Then your task queue is actually the tasks that have to be picked up and pushed for changes. This is actually the tasks in the task queue are actually scheduled by the scheduler. So if you see again, the task also have priority levels associated with them. They have a callback and they have start time and expiration time. So expiration time is nothing but your start time plus timeout. So we know that every priority has a certain timeout associated with it, and that will form your expiration time. So note that updates are not actually sorted by priority in the update queue, but by insertion. So new updates are always appended to the end of the list. And the priority is still important because when processing the update during the render phase, only the updates with sufficient priority will be included in the result actually. And if they do not have sufficient priority, they won't be picked up immediately. So now let's move on to understanding how all of this works together into the scheduler.
Kriti, approximately how much more time are we going to take? Because we have some questions from the audience as well.
I think this is the last section actually. It might take like 10-15 minutes max.
Okay.
Just a second. Looks like my system is okay. Otherwise, if we have questions, we can actually first take the questions and then move on. Anything is fine.
I think, yeah, let's take the questions because it was supposed to end at 5. So people might be waiting for that.
Yeah, so I see only 3 questions in the Q&A
There
panel.
are questions. There are almost 45 plus people on LinkedIn Live as well. So we have some questions from there as well.
Okay.
Yeah. Okay. So folks who are live on Zoom, if you have any questions, please put it up in the question section. In the meantime, we'll take the questions that are asked on Zoom, on LinkedIn. Yeah.
Okay.
Candy, are you there?
So I think there's a question on Zoom asking 5 seconds, 5 milliseconds. So whoever asked this question, actually the React will actually, in concurrent rendering, React will give your control back to the browser every 5 milliseconds. The 5 seconds that you saw, I think in the priority that was. The timeout associated with normal priority is 5 seconds. Don't mistake this with the 5 millisecond part. So how it actually works is that when we have to explicitly defer any update, okay, for which React exposes the use transition or your use deferred value hooks, that time they are assigned a certain priority and certain timeouts. So if they are assigned low priority, suppose that has 10 seconds timeout. So that update will be deferred or postponed for 10 seconds. And once your 10 seconds are completed, that means the expiration of that task, or like the timeout has been completed, and now the task is ready to move to, from like, the update is ready to move to the task queue. From the update queue, it's ready to move to the task queue, and React can start processing that update. That is what timeout means. What your 5 milliseconds thing is, so because React wanted to keep the application responsive, yeah, so there is this, there are two web APIs, is input pending and performance now. So it, under the hood, it actually uses that to determine if there are any user events. If so, you give the control back to the user, back to the browser, so that it can register the user input. If not, has the 5 milliseconds block passed? If yes, again give back. So every 5 milliseconds, you're giving the control back to the browser. This is a different thing. Timeouts are associated specifically with updates. Regardless of what update is going on, if it is not a synchronous or high priority update, then they will have some, they will render in that 5 millisecond block. And this timeouts is specifically for deferring your updates. I hope that answers the question. Yeah, next.
Okay. Candy, would you like to take the next question, which were asked on LinkedIn?
Yeah, sure. One second. So we have a question from Nihal. He's a full stack developer and a game developer. So he's asking, what do you think of using TypeScript plus React, using Docker with undocumented open source project is a nightmare.
Yeah, you can use, I think, TypeScript. I'm not sure very much how your Docker actually, if you're trying to deploy it on some like, on a repository, obviously you will use Docker or some other containerization libraries. But TypeScript, obviously, you can use with React. I think it's a great practice if you use TypeScript instead of JavaScript with React, because it gives you more control and better readability and writing cleaner code. So yeah.
Yeah. All right. Thank you. There's also one more.
Although there's no I'm not performance wise using JavaScript versus TypeScript, I wouldn't say there's much things, as long as you have handled it, but it pushes you to write much cleaner code and can result in lesser bugs, which like, mean you may need to debug. So with JavaScript, maybe you will enter the way the mindset of writing code is not much type oriented. So there's no type safety, and that can actually lead to certain bugs. But TypeScript gives you more control on that.
Okay. Another question from Rohit. He's asking when to use memo and use effect.
Use effect and use memo is actually completely different. So use effect is if you want to perform any of the side effects, like if you want, after your components are mounted, if you want to perform anything, any side effects, like maybe you want to display something or update the value of a component or call your APIs that render some data, all of this you usually do in use effect. Use memo is mostly to memorize your state updates. So if you want the previous state to be preserved in some way, or like, you want the updates to be more smoother, then the use case of these two is quite different. So I'm not sure how you're asking, which it's not an either or whether to use this or that. The use cases in which this two apply is different.
Okay. Yeah, I think that's it as of now from the LinkedIn.
Okay.
Kriti, folks are asking if they can get the presentation after the session.
Yeah, sure. I'll need time to put it through, because it's like, but yeah, I can share it.
Sure. So, folks, all those who want the presentation, I think that will be shared on Discord server as and when Kriti shared the same with us. So, yeah, just stay tuned.
Yeah, Kriti, there's one more question from Darshan. He's asking for async in STMGMT, which hooks are introduced?
I didn't get the question, sorry.
Yeah, it's there in the Q&A section.
Okay.
You can just have a look at it.
Okay, for async state management, which hooks I introduced. So for asynchronous state management, if you are asking for state updates, that then it is like use transition, use deferred value. These two are the hooks. And then there are like, changes to your suspense. So suspense for data fetching also has certain changes, or suspense has also some changes introduced for server side rendering. And so previously you couldn't use suspense with server side rendering because it was not supported on the server. Now you have APIs to support that on the server, because now the way you're sending HTML from the server to the client is in a streamable fashion. So you have a render to pipeable stream API as opposed to render to string API for server side rendering on this. And that actually supports all the changes to suspense. So your streaming HTML and selective hydration with suspense, that is a concurrent feature that you can use for server side rendering. And you can declaratively use you can use suspense for data fetching, so you don't have to actually use is loading state now. So what we would do is you would use declare a state like is loading, and based on whether it is your APIs or data has loaded, you would in a ternary operation you would show what component you want to use. Now you can just use a suspense around it. That will solve most of the cases. And specifically now for transitions, that is for deferring your updates, you have use transition and use deferred value hooks that actually let me demonstrate it now only so that you can use. So I was demonstrating the app wherein the user input was getting blocked, right? Now if we think of solving this with respect to React 18, we have something called this use transition hook that returns is pending and start transition function. So what we do now is for the list, you can have a state that is updated, that is delayed in its updation. And what we'll do is based on that, we will defer the update of that state using the state transition. So if you use the state transition API, your updates will be actually assigned to transition lanes, which take a lower priority. And that's why there'll be some timeouts attached to them. And now you can see that my input, which actually has the filter state, that will take your higher priority, because I am actually it will take discrete event priority because I'm actually typing in. And transition, this will take actually your lower priority. So if I rendered this app wherein I have made the changes. So I have done nothing as compared to the last app that we were trying. Here you were using the same state value for list as well as the input, but for the solving it with React 18, what we can do is we can have a new state value for the list, and that can be updated using the update to that can be delayed using state transition. So let's see what is the effect of it now in our app. So if we try to now update, I'm seeing the input field search query being updated immediately, and slowly in some time your your list is getting updated. So again, let me type SOA soap. You see the soap update was immediate, but the list got updated later. Because this is because your soap is, your input field is now taking higher priority, and it is and your list update is taking lower priority. So your rendering of that is delayed. So this is actually how you don't have to use any debounce and throttle on top of this now. Just using this will actually solve your case. And your UI transition is also very much more smoother. So until your update of the list happens, so until your list is updated, you can actually see that the previous list is still there. You're able to see, but once the delayed filter is getting updated, you can see the updated list. So this is actually just with React using these hooks, you can actually now solve this slow or unresponsive nature because of blocking render that you were seeing, you can actually solve this way. I think we are good there.
Yeah, there's one more question from Aditya. He's asking a React concurrent model versus use of web workers. What are your thoughts on it?
I think that's what we covered. Why we did not use React team mostly did not consider that was because it introduces much more overhead. We need to think about memory, extra memory, like initializations, and then more memory getting consumed and more serialization overhead being introduced. So it's not just that there's no side effect or there's no much extra thought that you have to put there before using a web worker. There will be more things introduced that might be more difficult to debug or optimize for your complex applications. But if we think about it, if we think about this approach of scheduling, obviously with web workers, I think it's the concept of parallelism. You have something running in parallel. And here, this is a different concept taken wherein we are scheduling it. So still there is one, single input, thread, which is, catering to all your updates, but it is scheduled, which is much more much more better, because if you see anything or our state updates, we can manage. It's not like on your web page, everything has to be immediately updated, because if you even think about as simple example as this list, the user is okay with waiting for a millisecond of time for the update to happen. And now this is not the case for all applications. Applications are faster. In a faster environment, they are faster. So even if you employ concurrent rendering, if it's on a fast device, the blocking render concurrent rendering is not going to make much difference. It's only going to mostly cater to apps or devices that are slower, like older devices or slower network connections. If you're trying to render it, the user is at least seeing that the app is responsive and not, frustrated by not having their interactions catered to. So that's what React. Actually, there's a thread, I think by Dan. I could not find it, but maybe I'll tweet about it. Why actually so Dan Abramov from the React team has actually tweeted why they did not go for the approach of web workers, but rather stick to the scheduling. I'll probably find that thread and tweet. So if you or put it on LinkedIn. So you can follow me either on LinkedIn or Twitter, and you'll get to, you can read that thread that Dan shared. Yep.
Yeah, so there's one more question from Darshan. He's asking, earlier you were talking about you can achieve this using a thoughtful bounce tool. Can you shed some light on that?
Yeah, you talked about you can achieve this using throttle and bounce too. Okay, so debounce and throttle are like these are the most important interview questions. So if you are not using debounce and throttle or have not used so far, please do go and check. So what debounce and throttle will do is they'll just sorry. Now when we are trying to write, what happens is with blocking render of React, if I type L, then it will immediately take it and filter the list. If I type L like LU, it will immediately take it. And not just this, if you simply take a search input and console log it, you'll get for L, you'll get one console log. For LU, you'll get one more console log. For LUX, you'll get console log. So your event handlers will be triggered for every time you do a key press. So debounce and throttle, what they do is delay this so that by some time, so you give a, mention a timeout for debounce and throttle also. And what it does is your event handler is only called in once for that timeout frame. So if you give like a 5 millisecond timeout, whatever I have typed in the 5 millisecond timeout, it will register that. It won't take it for every key press that I have done. So these are both a very important concept. Do go and read about it. So that's when also earlier we would handle that. So every time you search a query in the input field, your event handler input handler will get triggered, and you'll make an API call maybe, or you'll make a call to filter the list. Now, that should not happen on every key press. It's not necessary the user wants to filter the list when I type LUX on L only, LU only, LUX only. You only want it when I have typed. So user might take some time to, type all 4 or 5 letters of their query. And in that time, you can only trigger one call for the handler. So that is why debounces and throttle is used.
Okay. Okay. One more last question from Anish. He's asking, how can you learn more about concurrent rendering?
How can you learn more about?
Concurrent rendering.
Concurrent rendering. Okay. So there is this blog. So when React 18 was released, best way to learn about concurrent rendering is to read the documentation of React, their GitHub documentation, not just the documentation on their blog, that is react.dev. They also have a React working group, GitHub. Go and check that GitHub. They have when the new React 18 features actually came out, a lot of documentation was done by React team, because it was actually, see this, a huge change. So if you go to your React working group GitHub repository and React 18, there are so many things in the discussion forum, so many documentations. Just go and read this. How to use suspense, how to use transition, everything. What is we new introduced in React 18? What is how to use deferred value, selective hydration, everything. Suspense changes. What is new in suspense SSR? This is what I gave a talk on at React India actually. This is the holy grail for that talk. Very well explained. You can read either their documentation from the React working group, or best is react.dev. For the React 18 release, they actually put down everything, all the new features that they have released. So you can actually read it from here.
Yeah. So yeah, that was the last question, Kirti.
Yeah, I think what I'll do is we've all passed the bar.
Yeah,
So
past the time.
yeah, so let's wrap it here. If at all, this is just a request to you, if at all there's a good feedback and there's a possible opportunity, I would like to take another session to complete the scheduler part again. So let's
Sure,
see.
sure. Yeah, yeah, sure. We can like schedule. We would be happy to have you again. Like, maybe we can make it as a second series like of
Yeah,
this
yeah,
webinar, right?
sure.
So that would be really amazing having you back again.
So and that is actually would be my closing notes to everybody, is that every new feature need not be used. You have to understand the use cases that your product or application requires and what will solve it. But obviously staying updated is best, and for that you must please read the docs. They are the best they are the best resource to actually learn about any library. So, and also if you want to use the features appropriately and avoid unexpected errors, again, the docs are the holy grail. So do read the docs, and happy learning. Thank you. Also, if you want any resources, you can follow on, this is my Twitter and LinkedIn handle. I'll try to, whatever I spoke about, the resources, I'll try to tweet it. So if you follow me, you will get those. Yep,
Okay.
that's all, Candida.
Yeah. So, Kriti, thank you so much for, coming here and joining us for this webinar. Even though it was a very long session, I think it was a very, informative session. Like a lot of questions also did come back. So, thank you so much for joining us on this webinar like that. Hope to see you again next as the remaining edition of this webinar like that. And I would like to thank everyone who have joined with us today. Hope this session was very useful. We do look forward to see your learnings. You can maybe put in your post, or maybe you can hop into our server and share your learnings. If you have doing a LinkedIn post like that, do tag Kriti, like, because she have taken her time to explain about this. So please do share. Yeah, so thank you so much, Kriti, for having us here.
Thank you so much, everyone.
Like, that's
Yeah.